All right, so we have this problem. This is a pretty standard problem for what they call combining random variables, and basically saying that what's the probability that one is larger than the other one. But on this one, it says Mr. Hughes' AP Stat students on a district test score was approximately normal with a mean of 86.2%, a standard deviation of 3.4. Mr. Smith of scores were also approximately normal with a mean of 81%, 0.9, a standard deviation of 6%. What's the probability that a randomly selected student from Mr. Smith's class will be higher than a student from Mr. Hughes's class? So on this one, we need to start off by defining a variable. And I'm going to use H is the H is the score of a student from Mr. Hughes's class. And I'm going to use S for a score of a student from Mr. Smith's class. All right, also, this is not the only way to do this, but I'm going to put in another D. D is the difference, and I'm going to establish it as, and it says that Smith is higher. I prefer dealing with positive numbers. So I'm going to say that D for the difference, that's why I use the letter D for the difference, is going to be S minus H, Smith minus Hughes, which actually that does a couple things. One is now I can use the variable D, which is going to make it a little bit easier to write. And then also I've established the order of subtraction. So later if I forget, I can just look back up and see it's Smith minus Hughes. All right, so per normal, the mu is going to be pretty nice. So the difference of the average is the average of the differences. So this is asking for the average of the difference, and that's going to be equal to the Smith score, 81.9, minus Hughes' score, 86.2, which I'm not doing any mental math this morning. That's negative 4.2, 4.3, which I guess my trick about you getting positive numbers not necessarily going to work, but that's fine. All right, but don't forget, mu is always pretty nice. Standard deviation is going to be a little bit more difficult. For the standard deviation, again, we're going to give ourselves a nice big square root symbol, just like we always do with standard deviation. And I'm going to take Mr. Hughes' standard deviation, turn it into variance, and then I'm going to combine it with Smith's. Now, one thing we got to be really careful about is that is always going to be a plus. You never subtract when you're combining standard deviations. And I know that gets confusing. I will say this, when you see this type of problem, it's always going to be the difference of. So, I mean, that's just a step that you're just going to have to kind of get used to. And then I get I'm going to call it 6.90. Rounding it. So I got 6.96. So I'm just going to make that 6.90. So that's the new mu and new sigma of the difference between Smith and Hughes, which again means the Smith minus the Hughes squared. Now it said Mr. Smith to be higher than Mr. Smith. So I'm sorry, Mr. Smith to be higher than Mr. Hughes. So what I want to do now is I want to find the probability that D is greater than 0. All right. And then again, I now have my new mu and my new sigma, and now I kind of do normal CDF. So that's equal to, we got normal, excuse me. So we're going to do normal CDF. And we're going to do lower is 0. Upper is some ridiculously large number. 1,000 should be plenty in this case. Mu, and it's technically mu of D. I don't think the College Board really cares about the subletters there, but I'm going to go ahead and write it correctly because that makes more sense to me, and I like it that way, and it's my video. And then I go normal CDF, and I type in from 0 to 1,000, negative 4.3 for the mean, and 6.9 for the standard deviation. And I get 0.2, I'm just going to go 0.267. So then answer the question in a sentence. You would say, there is about a 26.7% chance that a randomly selected student from Mr. Smith's class has a higher score on the district test than a randomly selected student from Mr. Hughes's class. And there you go. So again, this is not an easy question. These are very difficult. Again, they always run the same play. It's just they're going to give you the mean and standard deviation for two things. It's always going to be minus. It doesn't have to be minus, but it always will be minus, because otherwise, how are they going to trick you into having to know to add the standard deviations together? But that's again, that's that can be pretty confusing. But there you go. We'll have more practice on these, and again, you will absolutely see one of these on your test. This is typically an multiple choice question. So I know you might be thinking, well, why do we do FRQ on it if it's a multiple choice setting? And it could be FRQ. But if you can handle the FRQ, the multiple choice will be easy. And the whole point that I try to approach is, let's make the test as easy as possible.